Okay, now we start recording to the cloud. And are these everyone who will join to the 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Andrei also. Hola. Now we have spare chairs. You can lay down on them. Sit here.
You need to move all these chairs.
It's very expensive meeting, you know. Should I pay? You mean? For this?
Well, I just hope that this will go virtual.
It will. Okay, we almost have everyone. Okay, let's wait for 1 minute and start. I think Alex also wants to be here. Okay, so far I will begin with a small agenda. It is not about Hashicorp Vault. As I already told you, this workshop will consist of 3 main parts. We will see the presentation where I will try to give you the understanding of what Hashicorp Vault is and what problems we are trying to solve with Hashicorp Vault. After that, we will go through a demo workshop. I will show you how you can install, configure, and some basic scenarios with Vault. And we will do it with Docker, so it's like 2 birds with 1 stone. After that, I will present you how we use the Vault already in mixed card service scenario. And after that, we can have questions and discuss with beer and pizza. Pizza will come later afterwards. So I think I don't need to present myself, but just for the records, my name is Artur Lomsadze. I work in Optile as a senior backend developer, and I work mostly in Optile X team. Yeah, let's, before we start, I want to say a couple words about the problematics. So we need to store account data, and we already do that with secure storage service. And this is perfect for PCI DSS. We already passed this. There is no problems here. But the question is, are we allowed to store account data simultaneously with CVV, CVC codes inside? And yeah, actually PCI DSS allows to do that during the transaction time. So, but the problem, are we allowed to do it with a homegrown solution like security storage? And I think it can be a problem. At least it can be difficult to pass the PCI DSS certification. And in general, it's still a big question for us. So in this case, it's better to use some certified third-party solution. And here are the main requirements, what this solution should allow to do. So first, we should keep the data, in our case it's CVC, CVV, only within the time of transaction goes. So this type of data shouldn't be persisted permanently. Also, we need to be able automatically dispose this data upon the transaction finishes, or if for some magic reason this transaction will go longer, or fails for some unexpected reason, we need to automatically remove this data also by TTL, time to leave meaning. So, and this data also need to be stored in encrypted format, and we need to protect it also with secure authentication mechanisms and security policies. And we need to provide also security audit in case when we have security incidents. So, and here where the Hashicorp Vault comes to help us. And yeah, we can store CVC and CVV data inside Hashicorp Vault with account data together. And it's certified solution to store secret data. And I think for passing PCI DSS, it will be much simpler. So what is Hashicorp Vault, and who is this strange animal with triangle face and many eyes? So we already use this technology in mixed card service scenario, and soon we gonna use it in OPG. Well, Hashicorp Vault is a popular tool used to securely store and manage sensitive information in modern application architectures. And it's an open source solution. There's a link on GitHub. It's also free for commercial use. And it has amazing documentation with free online courses. You can go from them and understand in deep and get, and these courses for different type of knowledges. So for example, for operations or for developers. And also there is a paid version for additional features like integration with HSM. It's a hardware security model, or for support also from the side of Hashicorp company. Now let's go through the key features of Vault. So these are secure secret storage. Secure secret storage means that Vault can be configured as a durable storage of some arbitrary secrets. And at the same time, Vault encrypts these data prior to persisting in this storage, so no one can steal them afterwards. And even if attacker gets access to the raw storage, it will be still encrypted with very secure mechanisms. Next term is dynamic secrets. Next feature, it means that Vault can generate secrets for different systems on demand. For example, when an application needs to access an Amazon S3 bucket, it can ask Vault for credentials, and Vault in turn will generate an Amazon VS key pair with valid permissions. And after creating these dynamic secrets, Vault will also automatically revoke them as soon as the lease is up. Next feature is data encryption. Vault can encrypt and decrypt data without storing it. So in our situation, we can use this feature as just encryption, decryption service, where you can pass the data you want to encrypt or decrypt, and you will get the appropriate version of this data in response. Also, it provides leasing and renewal. It means that all secrets in Vault are have a lease associated with them, and at the end of the lease, Vault will automatically revoke that secret. Clients are able to renew lease with through the built-in APIs, namely renew endpoints. Next feature is revocation. Vault also has built-in support for secret revocation, and Vault can revoke not only single secrets, but also a tree of secrets. And for example, secrets read by a specific user, or secrets some particular type, and it can be very helpful in terms of intrusions, in case of intrusions, or in case of just for key management. And finally, feature of audit. It's also very important because we need to have very detailed logs in case of security incidents to be able to investigate them. Good. Before going to the real workshop, I want you to meet the basic concepts of Vault. So we will have our terminology in head and can understand what is going on there. Yeah, this is the general picture of Vault interaction. I will describe it right now. Basic concept like storage is simple. I think everyone understands this. This is where this Vault can store its own data for functioning. So it can be different. It can integrate with a lot of different storage types, and some of them even I didn't know before I looked at this picture. Yeah. Next term is auth methods. This is how clients can be authenticated in Vault to be able to work with it. And there are also a lot of different authentication methods supported by Vault. For example, you can log in with even GitHub accounts or whatever. But during this workshop, we will see in details two interesting authentication method. It is token authentication and also uprole authentication. Token authentication, it's marked here. It's the default and basic method for every other types of authentication. And tokens have a few properties which are associated with them. This is the set of associated policies. We will see this during workshop. This is time to live for the token, whether it can be renewed, and also maximum usage count. And finally, it's token inheritance, meaning that child token can have at most the same level of privileges which its parent has. And all other authentication methods are built on top of this token method, and meaning that once the client was authenticated through any of these methods, it will receive the login token, namely login token, that can be used to send requests to Vault via API. And uprole method. Uprole method is recommended. It's not shown here. We will cover in workshop. It's methods recommended for applications. You just provide the application role ID and secret ID to log into Vault and these role ID and secret ID, these are kind of login and password to database or in any other standard system. So far so good. Okay. Next term is secret engine. This is very important component. This component allows you to store, generate, or encrypt data. For example, if some of you already worked with identity management systems, namely IDM or access management systems, you can draw a parallel with it. Using these secret engines, Vault can manage secrets inside other different other systems. So like IDM system. And you can develop also custom secret engine by yourself, because Vault supports custom plugins, and you can just include your plugin. Good. In the workshop, we will cover two main secret engines. So these are key value secret engine. It can be two versions, non-versioned or versioned. And this is where we can store some arbitrary key value pairs, secret data. And also we will cover Cubbyhole secret engine. It's very important. Secret engine is kind of special type of key value storage. And this Cubbyhole, it's like cozy box. This Cubbyhole is assigned for every token created in Vault. And once saving the data inside Cubbyhole using this token, you can fetch this data back also using only this token. So means that even root token don't have access to your data. It's like very personal. And of course, after this token is up, the cubbyhole is also destroyed. And this concept is very important to know. Finally, we have a policy. It's can also analogy with file system can be drawn. You can allow the creation or list of secrets or read, update, delete. Also, there is a operation sudo for everything. And these policies are described with mostly with two forms. This is the HCL, namely Hashicorp configuration language, and or you can do that with JSON, but Hashicorp recommends this HCL, and you can see example. Finally, we will see a response wrapping mechanism. Response wrapping mechanism is also very important for us because it's used when after sending the request to Vault, you want to deliver its response to some other system, but in very secured way. And you can see in this picture secret retrieval by the client, human or machine. So during this process, response will be saved inside the cubbyhole, so the secret response inside the cubbyhole with one-time, single use, and short-lived token. And afterwards, you can unwrap this data by providing this token and get the response, the real response with real data. And after that, this token will be destroyed. And cubbyhole contained this data also will be destroyed. So these are all main concepts. And here you can see how you can interact with Vaults. Of course, it has shiny UI. It's very flexible. You can do almost everything with UI, but we will not see too much into it. You can use command line interface, Vault, and also REST endpoints. What's interesting here that Vault command line tool can do the same amount of operation as the REST interface has. So you can use both, but usually I think everyone just uses REST because it's easier for development. For example, for operations, it can be easier to use, of course, a tool, command line tool. And during working with Vault, you can send requests, for example, with REST, and also it's like an analogy with file system, directory tree, and each secret instance is accessible via path. And the first component after V1 section is related to the mount point of where all secrets of concrete type are stored. Like shared secrets is type key value, cubbyhole intents for cubbyhole, and it's static, you can't configure that. And also transit, some transit engine for generating key value or encryption. Okay, and now our demo workshop. I need a couple of minutes to prepare. Okay, switch off the sound. Okay. So far, let's close this. Yeah, that's better. Can it be seen? Okay, let's do this full screen. Of course, I will use the Linux command line Linux shell, but I think you can adapt. After this workshop, I will send you whole information, whole scripts. You can play with yourself, and if you have Microsoft Windows, you can just reuse them in an appropriate way with Windows command line. Okay, everything I prepared here will work with Bash command line. I will go to the home directory. Okay, it's empty. Good. So we will go through the very beginning. First of all, I want to show you how to run Vault, configure and run it with Docker. So the first, I will not cover Docker in deep. You just can do the same on your local machine without Docker. You can just skip part of configuration with Docker, the configuration of Docker itself. So the first part, I already copy-pasted the text I prepared. I'm creating the Docker file. It's simple Ubuntu image where I just install some common tools which could be used afterwards. These are not related to Vault anyhow. And after that, I want to build my image. Docker will build image, and it means it creates kind of template from where you can already run a real container. And here's the command line to run. I will describe it to you. So first we run the container, and when you will use Docker, if you will use Docker, I really advise you to put limits on the logs, because on my machine, the logs were exploded when I tested this, and it took me 100 gigabytes, almost all my empty disk space. So be careful, always limit the logs. After that, cap add is not interesting for us. It's just some specifics. I also want to expose port 8200 because this is default port for Vault, and we will work through it. I will name the container which will be working like dev Vault, and it will be run from my Ubuntu image, which I already built here. And after running the container, it will run the whole operation system inside, kinda. I want it to be alive. This is why I do continuous ping. Okay. I think it's run. Let's check. Yes, it will show us. Yeah, it's working. Great. Now, next step. I want to enter inside this Docker container to configure it from inside. Actually, all we will do inside Docker, you could put inside this file, namely Docker file, and it will do it whole at once, and you don't need to go inside the container and configure it. So it can be automated this way, but I will go through all steps to demonstrate. We will go inside the container with these commands, and I want to have a bash command line. Now we are inside the container, the ID is the same. I want to go to home directory, and it's empty. Now let's download the Vault tool. It goes a bit longer. Unzip it. Okay. You see, it's just one file. So it's server and client and command line tool at the same time. You can do everything with just, I think it's perfect solution and very convenient way to work with. And to make this available from the command line, I will just put it in the user bin folder. Okay. Now we can check if it works. Okay, yeah. Now we have prepared our command line tool for working with Vault. So you can just download the Vault inside Windows in the machine and work with it like with command line tool. So far, so good. Now, I want to prepare the server. I want to run it. And to do this, I will create a couple of directories. This first directory is for configuration vault and for vault configuration. And the second directory is for vault data. Inside configuration directory, I will put this information. This is simple configuration of vault server, where you can see that we will store all data inside the path, vault data, and this is file storage. And I will expose two listeners, one listener for localhost to work inside the container and one outside, so I can work also outside the container through port mapping. And the port is 8200. And I want to disable the TLS because this topic is, you can configure afterwards, but I have also an example of configuration with encryption. So with TLS, so you can also see it afterwards. And this disable memory lock is also needed so far for demonstration. It's just difficult to configure and cover shortly in the workshop, so we also disable. And we also will turn on the UI interface. It's simple one line. Good. We are ready to start our instance. We just define the vault server command and define the configuration file. Now it's up and running. Good. Let's check if we can log into. Great. Okay, UI is also working. Now what I need to do, I need to open the second terminal. So this is server and it should be run. All these steps you could do with Docker, and instead of pinging inside, you can just do all configuration and run Vault, and it will be run inside the Docker container. This is, and there is also a very easy option to run Docker in memory. You just say Vault server slash Vault server dash dev. It's dev mode, and it will run without any configuration. You just download the command line tool and execute it, and it's already working. But I wanted to show how you can configure it. Good. I will move it to another desktop because I don't want to see it here. We will come later if we want to see some logs. Okay. To be visible, let's do that. What's interesting possibility in Vault, in Docker, you can connect as much times as you can inside the Docker container, and I will use practically the same command, almost docker exec -it. This E means that I want to export the environment variable, namely Vault address. So I could do that inside Vault. Actually, I can say export, and Vault address is this one, but you can do that with Docker right away. So we already have environment Vault address. Why I put it here? Because by default, when you use Vault tool, it will try to connect to HTTPS. And now we created the HTTP connection, so we need to define the proper address. Good. We started server, but we still didn't configure it completely. It's just server. Here you can see with Vault status command that the server is not initialized and it's sealed. Sealed means that Okay, let's go through it and you will understand. First of all, we need to initialize it. This simple command, first init, vault operator init. And here it will provide you these unsealed keys as well as root token. We need to store all these keys because afterwards you need to spread these keys inside the team. It's a good approach. It's like compound secrets. It doesn't have only one. And if you see now vault status operation, yeah, again, run vault status, and you can see that total shares is 5. It means that you have 5 unsealed keys. And the threshold is 3, means that you need to provide only 3 keys, any of them, to be able to unseal the data. And yeah, after that, the data will be available for you. So I will prepare, yeah, you can just type the vault operator unseal, providing the first key. Wait, something wrong. Probably. Right. Let's. Wait, let's save this data inside vault 2. Yep. Yes. Now you see the progress. It's 1 of 3 tokens. Let's continue. Oh. It's 2 of 3, and the last one. If you use the first one, nothing will happen. It will say you the same. Just 2 of 3. So, yeah. Yeah, again, you see it. 2 or 3. But we will use the third one.
And if you put around 1, it doesn't give you any error, right?
Yeah, it gives. We just got this error.
You got an error because the syntax was wrong, but if you put a correct syntax, but
it will show you. Yeah, we can.
Also.
Yeah, let's check. This error, 400.
I mean, this is not valid X base.
Okay. Finally, we unsealed the vault, and if we want to seal it back, for example, for some reason, just simple operation vault seal, and it, vault operator seal. Vault operator. Oh, wait. Scan. Yeah, right. This is very important because after we unseal the vault, we can't work with seal case. We need to provide the token already, and this is root token. So we need to copy this and to provide this as an environment variable too. It's very important. Now, finally, you can seal the data. Good. It's again sealed. So for any security incidents, you can even not shut down. You can just run command vault seal, and it's protected. It's good. Let's unseal it back. And the first one. Okay, it's initialized and unsealed because sealed is false. Great. Okay. Now, I think this is all we need to do to prepare Vault. Now, I can just exit, create new terminal, and I will do 2 terminals. On the left, we will have the kind of admin console. Now I will connect Vault through the port mapping of Docker. So it's already not inside Docker container, it's like my local machine, and I will connect to this Vault server. To do that, you also need to provide these 2 environment variables. It's Vault address and the token itself. Now, finally, you can check if it works. I just installed the Vault inside my local machine the same way. I put it inside the bin directory, so it's command line 2. Vault status. And yeah, we connected through this root token. Actually, it's not very secure way because root token is too powerful. So yeah, this is why let's create new token. And here you see command Vault token create with Orphan parameter. It means that this token don't inherit any policies from the root token. And if you recreate root token, it will be not disposed. You can get new root token, but if you dispose the old one and don't define the Orphan, the token will be destroyed too. So, and in our case, for example, we don't want to do that. Okay, we created the Orphan token. Here you can see the token itself and the token accessor. With token accessor, I will not cover in this workshop, but just in case, I will say that you can handle the token information, token lifetime. You can configure it. For example, if you need to extend its TTL, if it has TTL, you can also use token accessor without using the token itself, so you cannot expose the value. It's like identifier inside the Vault. Good. I need to take this one. And now, after I created the token, I want to connect from the client using this token. It's the same portion of information. Let's check if it works. Yeah, great. So now, after we have everything prepared, we have token, just it's simple case. This token is already has a cubbyhole, so you can store the data inside cubbyhole assigned to this token, and this data will be available with this path. Cubbyhole is a static, and as cubbyhole is key value storage, I want to put there several key values. So it's my value 1, my value 2, and values. Let's do that. Okay, data is written. And I'm doing this using the command line tool. Now, let's get this data back. Vault read, cubbyhole, and we say the key. Here we are. We have the data back. And we can also delete. So it's simple CRUD operations as in any database. But now I want to show, and we will now work on client side using the curl utility. So this way I will demonstrate how to work with REST API. I will do the same. I will create new token using REST API. And the path is auth token create orphan. So you don't need to remember all these paths because you can just go to documentation and see how to do that. They have amazing documentation. And in the response, you get the JSON object, and you can use this JSON object to do the same operations as you did with Vault command line tool. I want to create, first of all, I want to save data. And this data located here, I already prepared this in advance. Here it is. It's just simple JSON with account. And here, yeah, right, we have CVC here. So we can use it already to store securely. And here's, sorry, it's token creation. Now I'm saving the JSON inside. And you can see the path is exactly the same. I just defined the different key, test data too, but inside Cubbyhole. The data is saved. And this request was done with post, and in header, important stuff, you must provide the client token, which we created here. This is token. And also we can read this data back. And response is an object. It has some metadata like request ID, renewable, blah, 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 and the data itself. And this is get request here. And also with delete request, we just remove this data. So if we try to get it back, nothing we can get. Good. Now, a very interesting question was from Alex. I remember when we discussed, he was interested if these paths are not intersected somehow. For example, if we create two tokens and save data inside the same path, should these data be overridden by another token? Let's check this. I have here, I prepared two different pieces of data because I want to understand whether it was rewritten. Yeah, it's like customer, it's our GVT example, okay. And we have created two tokens. I need some time to prepare. And get this token too. Okay. This terminal is client. Here we configure Vault as an administrator. Here we just use it. We provide the first token for saving the data in this path. Oh, sorry, in this path as a test data. And after that, we use the second token to overwrite this data, to save the data. Because overwrite will be not correct, because when we get this data back for each token, we can see that the data is persisted. So every token has its own space. Yeah, it's personal cozy box. Great. Now let's go through more advanced feature is TTL. Now I need to do this very carefully because I will put TTL 1 minute and I need to do everything in 1 minute. Okay, let's take the token. We created a new token. And of course, we can save new data. We can get the data. Yeah. And this detail means that when token is destroyed after 1 minute, all data also will be destroyed. Let's see this. 1 minute should be up soon. Yeah, these are long 1 minute. At home it was much faster. Come on. Ah, it's already deleted.
Aren't you uploading?
Ah, I'm uploading. Oh, sorry. I need to get it back. It's already permission denied. So yeah, we can't get it back because token was expired already.
What happens if you call post with expired token?
If we call post with expired token, let's try. I think it just says that permission denied. Yes.
Okay.
So we just were happy to have not expired token during our post requests, but yeah, permission denied mostly. Great. This is very useful feature, but we have also one more interesting. It's use limit. It means that now I create token which can be used only 4 times. Actually, you can combine both these mechanisms, and this is actually how response wrapping works. I will show you later. Okay, we store data. This is the first invocation. We post data. This is already counted as first invocation, first use of 4 times used token. The next use is get, it's second. Now let's use 3rd time and 4th time and 5th time. We don't have already any data, and token removed, data also removed. So it's nice to play with this. Great. This was a bit advanced scenario, not so complex here, I think. So far, everything is clear. Good. Okay. Next scenario I want to show you is response wrapping mechanism, how it works. I also need to work fast because after some time this information will be wiped out. I want to create new token, and this token will be alive like forever because no TTL here, but I want the value of the token, its secret data, to fetch it, to deliver it to someone without exposing to me. It's interesting scenario. I use wrap TTL 60 seconds. It means that I will have one-time token generated for 60 seconds. And if I passed this one-time token to someone and he didn't use in 60 seconds, this data will be removed and we will need to go from beginning. And this token is also one-time use. So let's create. This is wrapping token. This is not data itself. I created the token, but I don't expose the value to myself. Well, what I need, what I want to do, I want to deliver the created token to the client. So I give this wrapping token to the client, and he invokes, oh, sorry, it's not this request. And he invokes the endpoint wrapping unwrap and passes the token we get here. And he got his data. His token, which was created during this request, and all other properties. And if we use this request second time, for example, some intruder get this token too, it can be impossible. It will be impossible because this wrapping token doesn't exist anymore. Great. Now, this scenario is finished. And of course, the client can use this token as usually afterwards to work with Vault by providing it inside the REST. So we create data saved inside the cubbyhole again, and we get it back, and we can delete it. So you can do whatever you want. Great. This was the token mechanism. Now, the next scenario will be, I want, for example, to create the shared storage, which will be accessible for different tokens. This was only personal information. And to doing so, I will enable secret engine cubbyhole, key value secret engine. So with this command, I'm enable secrets engine, namely key value, and currently it's not versioned. I don't want to cover this topic. And I want it to be accessible with shared secrets path. It's like a file system. We create catalog and say it's type of key value storage. And afterwards, I want to put a policy for this path because I don't want, okay, this is an example of this policy. I want some clients to be able to access this path. But for example, for some, I don't want to allow the access. This is why I need to create the policy, and we will afterwards create the tokens using this policy. And it means when we create, they will be able to go inside and do whatever they want. Oh, sorry. I need the dash command line to store the data. Great, so we can go out. Okay, this was just creation, the policy definition. So it's not policy itself. Oh, where did I create it? I need to go inside my path. Yeah, let it be here. Let's create here. Yeah. And store file. Yeah, ready. Okay, and now I will create the policy defining the file where the policy is located, and I will name it as the same. For example, shared secrets, the same name as a file name. Good. Now we have the policy inside the vault, and now I can use this policy to create my token. Good. Here's the token. And using this token, we can, yeah, it works. So send requests. We can store something else. Okay, we store payload 1. Let's store payload 2. And as I already told, we want to share the data between different tokens. So let's create the second token with the same policy. Vault token create policy shared secrets. We have the second token. Here I used post requests, but also we can use the list request. and it will show us all data stored inside these shared secrets. If I created any token with other policy, it would not have access to this data at all. It would be permission denied. I will not show that, just trust. Okay. Good. This was more advanced scenario, and now
How did you share them?
I created key value storage. Let's go here. I enabled key value secret engine, and I kind of created the folder inside Vault with name shared secrets. It's accessible with path. And I told that this folder will be type of key value storage. So this how you can instantiate the secret engine. Afterwards, I created the policy file with description what tokens with this policy can do inside this path. So they can create, list, read, update, and delete anything. After that, I created the policy itself, because it was just the file. I created the policy and told where its definition located, and that's it. And the final step, I define parameter policy with the name shared secrets. It's the name of policy during creation the token. And I can do that several times. It will create the tokens, and all these tokens will have the same privileges altogether inside this and the same data. Yeah, they will share this data. Yes, exactly. So far so good. And one more interesting mechanism.
But I have a question.
Yo.
Can you do with this same shared secret thing to have like parents, like one
Yes.
token that can read and write, and the other can only read? But
Yes.
how can you share them in the same policy?
You can define several policies and just
But all of them for the same directory.
yes, always, or you can define the policy for precise for directory. Wait, shared secrets, token create. Because if you, where is this command? Okay, it's better to scroll. You see, here I defined the path, and this asterisk means that everything is allowable inside this path. But I would, for example, define path inside this path and say that only creation is available, and define the different policy for this. And define also, like, for example, shared secrets, path test data, and after that I will define the policy with delete data inside shared secrets, and I will create token using this policy. So it means that this token can delete the data inside this path. So yeah, this way it's very flexible. It's the same as in standard file system. Good. So far we saw only token mechanism, but there is also a token authentication method. But there is also uprole authentication method, which I want to show you because we use these two approaches. Sorry. This uprole authentication is recommended for applications. If we check the documentation of Vault, you will see that why. Okay, now I want to enable uprole engine. This is security engine. And at the same time, I want to create the role inside the vault for my application, my super duper application. And I want this application to be able to have secrets from shared secrets folder. To have policies like I described there, but actually the policy says that we can have secrets inside shared secrets folder. And at the same time, I want these tokens, which will be created by this role, will live only 2 minutes. And if I define token max TTL, it means 0, I put it here, because you can renew the lease of the token. So before 2 minutes is expired, you can invoke some API for updating the lease, and the counter will be flashed, and the timer will go again. Okay, let's go through it, and you will understand. So we create the role, and we interact again with paths, with this path of role up role. And here I define my role, namely my super duper application. That is written. Now let's read the information about this role. Vault reads, I think this will be better, right? Not to see on the bottom. I should have done this later before. Okay, now we can read the data. Okay, where's my mouse? And it contains some additional metadata, and you can see we have token TTL as we defined during the role creation, and token max TTL also is 0 seconds. I will not cover all these topics. Good. Okay, role is created. Now I want to have a role ID and secret ID. So I want to create the login and password for instance of the application, for example. I can do this with vault read command and define the up role, my super duper app, role ID, and it will get the role ID. This is our login. Wait. I will preserve this for the future use. Okay, put it here and here. So, good. This is just login, but we also need to have a password per application. In this case, we will use this command. Vault write, it means that create please me the password per each instance of application. So the role ID login will be the same all the time per instance, but the password per each instance will be different. And at the same time, I want to deliver this password, secret ID, in secured way. In this case, I just wrap the data with response wrapping mechanism, and I define for which role. And here's our wrapping token. Yep.
What is the difference between role and normal?
Between what? Sorry.
Role and the normal tokens.
Between role and token. Okay. For role, you can assign like policies and use this role several times to create the, again, kind of tokens, secret IDs. And these, after logging into Vault, the application will get login token with which it will have these policies. So these policies will be already defined for them in advance. You don't need to create the token itself. You just say application login with this token, login with this secret ID and role ID, and you get this information for you. And you get these security policies at the same time.
Creating the token with the attached policy.
You can create token with attached policy, but it's not considered as a secured way. I will show you later why, okay? Oh, okay, I need to, oh, I think this token is already up. I need to create it because probably the release already finished. Let's try. Ah, yes, let's create it again. Alt right, get wrapping token. Now we unwrap the data back. And here's our secret ID and also secret accessor. You can manipulate with metadata of this secret ID using this accessor. And we put it here. Good. After we get all this data, secret ID and role ID, here we can log into Vault. Application uses this endpoint of uprole login with post methods and provides this login information. And here we already have our client token. Now, you can send requests to Vault with this token and work with your path, which we configured, shared path. Using secret ID and role ID, you can do that. So you already have login token and you can now send requests. Okay, this is data we already stored with other tokens, our clients. And we can put something new there, like payload JSON. Okay, let's try to read it. Yeah, we can read. And we defined the token with TTL 60 seconds. So after some time, this token will be already disposed, I hope. Okay. Ah, yeah, it's not 1 minute, it's 2 minutes, as you remember. So yeah, we need to wait another 1 minute to this token be expired. Okay. Oh, post get. I should have done in 1 minute, but sorry. Finally, yes, we get. Now, why we need role ID and secret ID? Because application can log in again with the same data and get new token. And it can also work with it for 2 minutes, right? But this time, I don't want this token. Oh, let's try first, does it work or not? Okay, we stored the data. Let's get the data back. Yeah, cool. I think it works. Let's check the get. And it gets data. Great. And now, for example, we don't wait for 2 minutes. Now I don't want this token to be expired. I want application every time to renew this token, this lease. So the token will be the same, but the lease duration will be, the lease time will be extended. You can do that with renew self endpoint. So that's better. Auth token renew self, where it's post request, where you provide this login token with which you get from after the login into Vault. And after that, the lease duration again 120. So this way you can keep application logged in inside the Vault, but once application is shut down, no one who stole the token already can use it after this TTL. So it's a very secure mechanism, and actually what I expected from Vault, and it was not implemented by them because they have different type of thinking. I expected they, after renewing self, they should have provided the different token value. So it would be more secure way. So yeah, every time you get new token, and if, for example, application failed for 1 minute and before 2 minutes it up again, it can use renew token and get new token, and this works further again. It works further. So potential intruder, if he gets the old token, he can't do anything already. But actually, they just decided that only root can create new tokens. So in our terms, sorry, not root, only parent can handle, manipulate with token living time, let's say, and create new tokens. In our terms, we have a parent, this is secret ID and like login and password, secret ID and role ID. Okay, great. I think we went through all main topics I wanted to describe, and let's go back to scheme. Actually, what mechanism we get here is shown on this scheme. So we create the policy and role for applications. After that, we get the role ID from Vault and generate new secret ID. And some guy, operation team, delivers this role ID and secret ID to the application. Statically, application authenticates inside Vault, gets this short living token and works with it, regularly renewing it with self-renew endpoint. Or you can even renew with another role by using token accessor. So in this case, you will not expose the token to someone, but you can say, I want, for example, you to handle the lease duration every time, to extend it every time for me. So you provide him token accessor and he does this for you. Yeah, why I described everything for you here, because all these mechanisms we already using in mixed card service scenario all together and mixed. I will not describe what mixed card service is, it's the topic for later, but I can say that we have the Java class, let's say, or service, namely encrypted storage. And this is service which exactly works with Vault. So all interactions go through this encrypted storage. And to be authenticated inside Vault, this service needs to be deployed somehow. This is where I think it's very important for operations to know. We discussed the plans to use some automation tool, and with Jonas also. And most probably it will be Nomad. I don't know yet. It's still a question in discussion. This Nomad tool will provide this access for us, for our service. And how will it be? It creates, we configure the up-roll authentication involved in advance. And after that, we provide automation tool the information how to create the secret IDs. So we have login already inside this encrypted storage. We hard-coded it. No, of course, we not hard-coded. We provide it with Ansible repository additional, but it's static. And what we need to get back, we need to get back secret, password. This is where automation tool should come and provide it for us, but it should not be exposed to automation tool itself. This is why it's wrapped token. It creates it uses the response wrapping to get the token, wrapping token. It provides for automation tool, and this automation tool runs the service providing wrapping token. So this automation tool doesn't know the token value. Now, encrypted storage can authenticate with role ID and wrapped token. It unwraps it, logins with role ID, secret ID, and gets login token. Finally, we can work with it. We can send requests, execute operations like even create token. We can create token because we created the policy for this. We allow this role, this particular role for encrypted storage to create new tokens. Okay. And of course, this token is rotated, not rotated, is renewed. So each time the lease is expired, before the lease is expired, we update the lease again. And this is general scheme how we should deploy this application inside on the production systems. So yeah, we statically, some admin guy will include the role ID inside our application with Ansible repository. It will embed it, but we should also provide some trusted entity. This trusted entity should be very secured, and this trusted entity, in our case, it should be probably Nomad. It will provide us the wrapping token, and we afterwards can work with it. So application will wrap secrets, and after that it can send requests. And also our interaction scheme after being logged in, it's just logging in inside Vault. We can send the data, and as we store account data together with CVC, CVV, we need to be able to delete this by TTL or just delete manually. This is why we're using cubbyholes. On this scheme, this is Mixed Card Services, our application. For example, when we need to save some accounts together with CVV, it goes to encrypted storage, which in turn creates token for us. And this token is Orphan, as we already saw this in workshop. And this token has TTL for us, it's 3 hours, because we have a very long session inside the application. We can use this token during 3 hours. And we save token inside the cubbyhole. We save the data using this provided token inside the cubbyhole. Save account in cubbyhole method. Because once, for example, we forget to remove the data, or as I told, some unexpected situation happened and our application fails, the data should be disposed itself. And in this case, we don't provide any additional services, which is very useful. We don't need to monitor them because any additional service needs to be monitored, run, and handled somehow. It's done by Vault itself using cubbyhole mechanism. And of course, we save this token inside the key value storage. Why? Because we need this token again when we will read data back from Cubbyhole. So this is next step. We need to reuse this account data. We say please give us the account by some key inside the Cubbyhole, inside the key value storage, and it gets token back for us. And after that, we can use this token to get data back from Cubbyhole. And delete operation happens a bit different. Here we use, this first steps are the same. We provide the key to key value storage, please give us token by this key. And we invoke endpoint for self-revocation. It means that providing this token that we get here from key value storage, we say, now, Vault, please dispose this token for us. And after it's disposed, the data will be wiped out. It means that, yeah, you don't need to execute delete operation by yourself manually. Vault will do it for you. This is also very good. And this mechanism I have tested on my local machine. We implemented it in Java, and here you can see performance test results. I provided 10,000 objects, type of list string because it's Java, and the size of this matrix is 150. I generated the values with random UI, so all values should be different. And I create, per each object, I try to save it, then 3 times read, and after that delete. And for all these 10,000 objects, sequentially, this happened 27 seconds. And if you run in parallel on my laptop, it depends, of course, on the computer cores, processor cores, it was 11 seconds. But what's really important that this is very fast, I think. So it's from 1 till 3 milliseconds per object to doing all these operations. So this solution can be used for high load if you need to do something like that. Yeah, great. So I think this is almost everything I wanted to show you in this workshop. I hope finally you will not be scared of using it if you need to. Yeah, and what can be other use cases which can be used for us inside the, for OPG core, inside our company. You can store secrets data as we discussed, generate even key pairs. There are secret engines for generation key pairs, like for SSH, for example. You can sign and verify data. You can generate hashes, schmuck of data, act as a source of random objects. Also, there is engines. You can use it for providing access for applications to resources, or like IDM system to manipulate with data. Or we can use it to generate tokens and credentials for APIs and manage their life cycle using Vault, and much more. And for me, this Vault looks like something, this Swiss Army knife, but actually it does everything considered only with secure data, all secrets. So thank you for your attention. And yeah, this is probably it. And if you have any questions. Yes.
For your performance test, you used file as a...
For my tests, I used the in-memory configuration. Yeah. Oh, wait. I need to recheck because I configured Vault locally also, and I don't remember. Did I use? Yes, it was in-memory database. So yeah, actually we need to check this inside the file, for example, or Vault actually can, we can configure data storage like inside some Mongo even. We can use Mongo for storage this data and make another tests and say how many time will it take. I can do that and say afterwards if you're interested. Okay. Yes, please.
Is there a mechanism to make it so that people can share tokens? So say for instance I get a token to access data, I can just pass it across the desk in a random room?
Well, I think this is not intended, the token is something personal. And if you want to share your information, of course, this vault is instance on some server. So it means that you are not allowed to share information without confirmation from developers or from operation team. And in this case, you need to ask them to create the token to be able to fetch this information. And they will provide the token for another guy in this case. But tokens are personal stuff and you should not share them between. Of course you can, but no one will know this. Yeah, but it's better not. Yeah. Okay. Other questions? Okay, if there are no questions, I think this is it for us. And everyone likes kittens, so yeah, it's so cute picture. And I think it's time for pizza and beer that I promised. I hope they already ordered this. Oh, we need to check because I don't know. I asked to, but we can have beer. We start from beer, and if you have some questions, we can discuss it together. Please come. Yeah, I will be glad to answer. Thank you. Yeah, that's it.
By the way, Volt has their own Docker image that you can use.
Yes, I didn't tell this, but actually, yes, they have Docker image and you can configure everything already. I just wanted to show you how you can do that localhost.
Yeah, okay.
Yeah, because Miss.